Good morning, students. Today we will discuss about alkaline earth metals properties. These are the six block elements. So here alkaline earth metals. So alkaline earth metals are secondary group elements. You are already given secondary group elements. So S block elements means alkali metals and alkaline earth metals. We are already discussed about the preparation methods and properties of alkali metals. Now we are going to discuss about the alkaline earth metals. So alkaline earth metals are secondary group elements. Which elements? You already know that one: beryllium, magnesium, calcium, strontium, barium, radium. So these elements belongs to secondary group elements. So radium is a radioactive element. Radium is a radioactive element. It is a radioactive element. Therefore, actually, the general electronic configuration is NS2. So, general electronic configuration is NS2. Outermost only 2 electrons are there. Outermost electrons, how many electrons are there? 2 electrons only there. So, beryllium, magnesium, calcium, strontium, barium and radium. So, here once you observe the 1s2, 2s2. Therefore, I will write helium 2s2. Neon 3s2, argon 4s2, like this. Krypton, xenon, radon, like this. We can write the 5s2, 6s2, 7s2 electronic configurations. So here, you know that one. This is the beryllium. Beryllium atomic number is 4. For 4 we are adding 8, 12. 12 plus 8, 20. 20 plus 18 we get. 20 plus 18, 38. 38 is the strontium. 38 plus 18. 38 plus 18. Next one we get this one. 32 we get this one. So these are the electronic configuration of secondary group elements. So general electronic configuration of secondary group elements is NS2. So therefore, first we will discuss about the general properties of alkaline earth metals. We are discussing about the general properties of secondary group elements. So one more thing. So first element, beryllium, magnesium, calcium, strontium, barium, radium. So you know that one first element is exhibit different properties when compared to the other elements. So beryllium exhibit different properties. These properties are called anomalous properties. So these properties are called anomalous properties. So what are the anomalous properties? So here only magnesium can exhibit diagonal relationship. So diagonal relationship is exhibited by only magnesium. Diagonal relationship. So diagonal relationship is exhibited by the magnesium. So lithium, sodium, potassium, rubidium, cesium, francium, beryllium, magnesium, calcium, strontium, barium, radium. After that, next one is carbon, silicon, Next, boron. Boron, aluminium, gallium, indium, thallium. Next one is carbon, silicon, germanium, tin, lead. So here we already discussed in case of S block elements, these two are exhibit diagonal relationship, and beryllium and aluminium are exhibit diagonal relationship, and boron, silicon is also exhibit diagonal relationship. Therefore, beryllium and aluminium are exhibit diagonal relationship. So that's why beryllium exhibit different properties. So once we will check what are the similarities between beryllium and aluminium. So except beryllium, remaining magnesium, calcium, strontium, barium, they won't have. Means it is not related with aluminium. So magnesium can exhibit diagonal relationship with lithium. So here beryllium, oxide of beryllium is amphoteric. Oxide of amphoteric. Next one is oxide of aluminium is also amphoteric. Amphoteric in nature. Next one, beryllium hydroxide is weak basic oxide. Aluminium hydroxide is also weak basic oxide. And beryllium carbide, Be2C on hydrolysis, same product is formed. Aluminium carbide on hydrolysis, both are formed the same product. So these are the similarities. Because why beryllium and aluminium are having similar properties? Because of same electronegativity and same size of the cations. Because of these two reasons, they exhibit similar properties. Similarity in the properties is called as diagonal relationship. Diagonal relationship. After that, general properties. General properties. First one is atomic radius. So you know that one. Atomic radius and ionic radius. So atomic radius and ionic radius gradually increase in any group. So if you take any group, atomic radius gradually increases. Beryllium, magnesium, calcium, strontium, barium, radium. So atomic radius gradually increases because number of shells increases, therefore atomic radius is also increases. It is also observed in the ionic radius also. So for example, Be plus 2, Mg plus 2, Ca plus 2, Sr plus 2, Ba plus 2, Ra plus 2. If you take all these, radius, ionic radius is also increases. Therefore, we can write the ionic radius order or atomic radius order is like this. Be plus 2 is less than, Mg plus 2 is less than, Ca plus 2 is less than, Sr plus 2 is less than, Ba plus 2. Like that we can write the atomic radius order. So after that, ionization potentials. IP. So, what is the relation between IP and atomic radius? If atomic radius increases, IP value gradually decreases. It will happen in the same, it will repeat in the same any group. So, therefore, when you observe the IP values from beryllium to barium, because radium is a radioactive element, that's why we can't discuss about overall properties. We are not comparing the properties of radium with other elements. That is the important. Therefore here we are discussing about the, except beryllium, we can discuss the properties of other elements. That is important. So here, so beryllium, magnesium, calcium, strontium, barium and radium. So IP values also gradually decreases. So IP values from here to here, IP values are gradually decreases. So here decreases. So why? Because atomic radius gradually increases. Beryllium to radium, atomic radius increases. So if atomic radius increases, what happened? The tendency to attract the electron towards itself of the nucleus will increase. So decrease. So that's why you can easily remove the electron from the outermost orbit. That's why this is the reason. So this is the one of the reason for that. After that, next properties we are discussing. One by one we are discussing about the properties. Next one is oxidation states. Oxidation states of secondary group elements. So when you observe the oxidation states of secondary group elements, common oxidation state is +2. There is no exception in this. Common oxidation state is +2. So here B, beryllium, magnesium, calcium, strontium, barium all are exhibit +2 oxidation state only, because they having outermost NS2 electrons. If they can lose these 2 electrons, they can easily get the stable electronic configuration, that is NS2 NPC's configuration. Therefore, they can easily lose the 2 electrons. If they can lose the 2 electrons, what happened? They get 8 electrons in the outermost orbit. So that's why this is an easy process to get cations. So this is also one of the important properties. After that, electronegativity. You know that one. Electronegativity gradually decreases in any group. So that is one of the property. Next one, electropositive nature. Now we are discussing about electropositive nature. Electropositive nature. So what is electropositive nature? The tendency to lose the electrons is called electropositive nature. The tendency to lose the electrons is called electropositive nature. Electropositive nature is directly proportional to the metallic nature. So electropositive nature is directly proportional to the metallic nature. This is very, very important. So if electropositive nature is increases, metallic nature is also increases. Therefore, from beryllium to barium, metallic nature gradually increases. So metallic nature is also increases. So if metallic nature increases, what happens? Acidic nature of oxide will affect on the acidic nature and basic nature of oxides. This is very, very important. So, for example, if metallic nature is more, basic nature of oxide is also more. You know that one. Metallic nature is directly proportional to the basic nature of oxides. For example, if they are given like this, BeO, MgO, CaO, which one is more basic in nature? Calcium oxide is more basic in nature because the metallic nature of calcium is more than beryllium and magnesium. So this is very, very important thing. So therefore, if electropositive nature increases, metallic nature is also increases. If metallic nature increases, what happened? Basic nature of oxide is also increases. This is the relation between electropositive nature, metallic nature and basic nature of oxides. So this is also one of the important property of the alkaline earth metals. So general electronic configuration is Ns2, therefore they can easily lose 2 electrons. These are the general properties of alkaline earth metals. So in next class we are discussing about the chemical properties and everything about the, already just we are given the alkaline metals and alkaline comparable properties, but we are separating the properties.